So in this video, I would like to explain about class association rule. And I'm going to use the Colf dataset. Class association rules, sometimes it can be shortened as CARS. So class association rules, it aims to find relationship between certain items and a specific class label or a target variable. So the key point is the target variable. So we have a class label or the target. That's why they call it class. It attempts to find out which item or attributes that are most strongly associated with a particular outcome or category. So let's get back to the dataset that you have before, which is the golf dataset. So play golf, okay? No, when the outlook is rainy, the temperature is hot, and the windy is false. We know that these three are the attributes, and the play golf is the target. Yeah. So let's use this data set to represent the class association rule. Interestingness measures. We want to learn one more measures. We call it correlation or leaf. So let's say I'm just using only two columns, okay, windy, golf. Okay. So if the condition is windy true, then the call of yes. Windy false, the call of yes. Windy true, the call of no. The windy true, then the call of yes. Okay. So we have those data, and then we can make a kind of table like this one. So we can have how many golf, okay, and windy. So if the condition is windy and golf, yes, so there are 2000 data. If the condition is the person is playing golf, yes, and it is not windy, okay, they are like this one. When the condition is not golf, so the person didn't play golf and it is windy, 1000. And when the person do not play golf and it is not windy, 250. So this is represent the number of customers. Now we can measure the support and confidence. Do you still remember? Support and confidence. So the support for this one, okay, the support is 40%. When we want to see the windy, this is X, and the play golf, this is Y. How can we get this 40%? As we know that the support is the total of windy and play golf divided by the total transaction. The total transaction means the total data. So the total of windy and play golf is 2000. And the total of the transaction or the total of people is 5000. Then we have like this one, 2 divided by 5. This is 0.4 or 40%. Okay. So how can we get this confidence? Okay, so this is confidence. How can we get it? So we can calculate like this one. We know that the windy and golf, they are 2000. So if you still remember, windy and golf, it means the formula will be windy. No, the formula will be windy and golf divided by the number of windy. Okay. So what is the number of windy and golf? The number of windy and golf is 2000. And then how big is the number of windy? The number of windy here, the summation is 3000. Okay. So we can get 66.7%. Oh, this mention it is misleading. Why? So the customers, the overall customers who play golf, the number who play golf is 3750. Okay. But there are 3,000 who we have when the data is windy. Okay. So this a little bit confusing. Okay, 3,000 data we have who but the customers who play golf and not golf, and we have the customers who play golf is 3,750. Okay. So this number somehow is still misleading. Okay. And the other thing we can also try is if it is windy and then not golf. If it is windy and it is not play golf, how can we get this one? 20%, it is from the 1,000 divided 5,000. And then 33%, it is from the 1,000 divided 3,000. 3,000 is from the total of windy. We can say this is more accurate with lower support and confidence, but still, we need to figure out whether it is a good measure for these two cases. Yeah. So there's another measure, we call it correlated events, or yeah, we will learn about leaf, how to measure the dependency and how to measure the correlated event. Is there any correlation between windy and play golf? Yeah. So we use leaf to measure this one, and the formula will be the probability of A union B divided by the probability of A multiply the probability of B. So for example, I want to know the leaf when the W, let's say is windy, and this G, okay? So this negative G means not G, okay? Not golf, so not playing golf. Then in this case, we will see the probability when the person when it is windy and not play golf. The probability when it is windy and not play golf. Then it is 1,000 divided by the total data, 5,000, 1,000 divided by 1,000, and divided by the probability of A. What is A? The probability of windy. The probability of windy is 3,000 divided by 5,000 divided by the total data, multiply by the probability of not playing golf. The probability of not playing golf is 1,250 divided by the total data, which is 5,000. Okay. Then we get the value 1.33. Now, let's see if we have the leaf W and G. So W means windy and G means play golf. So we have windy and play golf. Windy and play golf. So there are 2,000. Then 2,000 divided 5,000. So this is the probability of A and B. And it is divided by the probability of windy. The probability of windy is 3,000 divided by 5,000 multiplied by 3,500. This is the probability of playing golf. This is 3,750 divided by the total data 5,000. So we got 0.89. By the definition, if leaf is higher than 1, then strong positive correlation. Or we can say the association rule is meaningful. Okay. So this is the criteria, higher than 1. When we do with the class association rule, we can also look at the top K class association rules. It means we do not need to consider all the association rule. We just need to find the top K. Top K means maybe if it is top 5, then we need to find only the top 5 from the rules. Okay. So we can set the minimum support, we can set the confidence. Yeah. But sometimes it is difficult to know which one is the best for our data set. So top K algorithms aim to find the top K most interesting cars based on some criteria, maybe based on the confidence or leaf or the combination. Okay. Now, let's see how we can do with the data in Golf dataset. In the Golf dataset, if you look at the dataset, in the dataset itself, at the first you know that when we do the classification, we will put the play golf as the target. The remaining is the attribute. Okay. So this is the data. And you can get the frequent item set like this one. Let me just skip this one. For the column, okay, if you learn the classification, you need to specify the target. But in this case, we cannot specify the target. So even though it is the target, we need to put into the features. We need to put into the attributes. Then the features, there are four. This is outlook, temp, windy, and play golf. Now, when you finish with the selecting the column, we can figure out when the association rules, and I want to specify when the association rules, yeah, we have the X and Y. So the Y is the consequent, and we want to specify only play golf equals to yes. So you can specify here. Okay? You can specify here. Play golf equals to yes. Okay? So the what is golf equals to yes. And what you can see from the result is all of them are showing when the consequence is play golf equals to yes. Even though there are some of the items not only play golf yes, like this one, we have overcast and then we have temperature cool. Yeah, you can limit. For example, this is the number of items. So you want to limit into one. And you can see the consequence, it is all only one. Okay. And you can also make the support. Yeah, you can change the leaf. Okay. Let's say I want to know only the higher leaves. And this is the higher leaf. Then you can examine. Maybe I want to check 1, 2, 3, 4, 5. Okay, so in this case, okay, if I check this one, 5. Okay, 1, 2, 3, 4, 5. We call this is top 5 association rule. Okay. When we want to check the top 5 association rule, then we can analyze with this one. So your analysis about this data, it is important. Okay. Let's say if I ask you, show the top 5 association rule, then you can show this one and then do some analysis. Okay. In this case, the first, okay, the person will play golf when the temperature is cool and the outlook is overcast. The person will play golf when the outlook is rainy and the temperature is cool. Oh, it's very interesting. Okay. And the person will play golf when the temperature is mild and the outlook is overcast. But you can see here, the lift is high. But what about the support? Okay, the support is very low, 0.07. It means the data is very small. Even though the confidence is high, but the data is not that much. Even though we can see the lift is very high, but not so many people will do with this golf playing during the rainy. Okay. Then you need to find the best alternative of these measures. Not only based on the leaf, but you can also check. You can also check based on the support. So we can look at this one. If the support is sorted, Then the support is high, 0.4. Okay, if the support is 0.4 and the lift is 1.1. Okay, maybe this is one of the best analysis. When you play with golf, the condition when the wind is false and the confidence is 0.75. Okay, this is quite high. It means I can just make the marketing. Okay, the analysis is when the wind is false. Let's do the marketing to promote the golf. Why? Yeah, because many people, yeah, in this case, we can say when the wind is false, the support 42.9% people play golf with 75% confidence. So let's do the marketing to promote the golf when the windy is false. Okay. So this is one of the analysis that you can do if you do with the orange and for the exam. I think I need to see this kind of analysis. And the other thing is, yeah, you can look at the option. Okay. So as I mentioned to you, we can make the filtering. Okay. If you are in the association rules when the golf equals to no, yeah, it means you can look all the antecedent and the consequence, and you can also click on the leaf and then check on the support, and then you can check on the confidence. Yeah. So which one is the best measurement? Yeah, you can look at the combination between the support, the confidence, and the leaf. And you can also do some kind of modification on the parameters, whether the support is this amount or the confidence of this amount or the rules. Okay, so this kind of things will affect the decision. Okay. And when also you know the class which is golf, so you can also filter it, and then you can define how many items that you want to use for the analysis. Okay, so I think that's all about the class. So we already learned about the data integration, and you learn about the association rule and the class association rule. So we will meet again after this week. And please watch the video for preparing your exam about Orange. Thank you very much for listening this video. See you in the class.